Okay, so as you hopefully saw in your transformation activity, and also I'm counting on some prior knowledge here, and that is that quadratic graphs, x squared graphs, make parabolas. And the parabola is either concave up or concave down. So just in terms of the right side up or upside down, we call that concave up or concave down. But what we need to kind of clarify for this, where we're going with this, is that on any concave up graph, there are actually two kind of sides to that. So check it out. There is symmetry on this graph. And the symmetry always passes right through the vertex on a quadratic function. But once you acknowledge that symmetry, I'm trying to color code here, so bear with me. Once you acknowledge that symmetry, you'll see that a concave up graph has two portions. It has a decreasing side and also an increasing side. So let me actually write down. So this is decreasing, D-E-C, decreasing. And even though it's decreasing, it is still decreasing concave up. So a lot of students think that just because something is concave up, that the graph has to be going up. Yeah, that's not true. Concave up, the graph can still be coming down directionally, decreasing, but yet decreasing in a concave up fashion. And then the other side of the concave up curve, you'll notice, is increasing. And so that portion of the graph is increasing. And yet, yes, still concave up. So just because the entire curve is considered concave up, within that concave up curve, you have a decreasing section that's concave up and still an increasing section that's concave down. So with regards to what it means to be concave up, okay, all that that means is that the rate of change along this curve is always, always, always increasing. So check it out. If I were to just imagine, I'm going to make up numbers right now. If I was just to imagine what the slope is, right there. That's a negative slope, and it's pretty dang steep. So I might say that the slope right there is like -10. And then as I progress along the curve, like let's say right here, okay, well that's still decreasing, but it's not nearly as steep as it was prior. So I'm going to make up a number. Maybe the slope right there is only -4. And then what about if I come right here? The slope right there is still slightly negative, definitely not as negative as it was before. So if I was making up numbers, we might say that the slope is -1. And then notice as soon as you round the bend, well then your slopes officially become positive. So like this slope right here. Well, that's a positive slope on that side of the curve. I'm gonna make up a number. It's not very steep, so I'm gonna say that the slope is just about maybe 2. But then if you go further up, the slope right there is definitely positive and it's really steep. So I'm going to make up a number and say that maybe the slope is +9. So if you look at the trend in these numbers, these rates of changes, they're increasing. -4 is technically bigger than -10, right? Think about it on a number line. -10 is there, -4 is 2. So those rates of changes are technically getting more and more, they're getting closer to 0. How about that? So these negatives are getting closer to 0, which is an indication that technically they're increasing. So you've got -10 and then -4 and then -1 and then 2 and then 9. They're always progressing this way on a number line. They're getting, technically they're getting bigger. Less and less negative or more and more positive. So in terms of their concave up behavior, You'll know that something is concave up if the rate of change is increasing. Okay, so if you were looking at a table or something and you were trying to decide if it was concave up or not, you could just go look at those slopes. And if the slopes are increasing, then you've definitely got concave up. And if they're not, then you don't. So again, concave up, it's like a right side up parabola, but nonetheless, within a concave up curve, you have the decreasing portion, decreasing concave up, and then also the increasing portion. Okay, well now we're gonna have the same conversation for concave down. So let's see, can I move this? Yes, I can. Okay, so this is my concave down image. But again, within that concave down image, two sections. So one part, switching colors here, use blue to be consistent. So this side of the concave down curve just happens to be increasing. If you imagine driving your car along that curve, you're going up. So just because it's concave down doesn't mean the direction has to be down. You see the difference? So this section is technically increasing. It just happens to be increasing in a concave down or up, sorry, increasing, oh no, that's right, increasing in a concave down fashion. I was right the first time, okay. Increasing, but in a concave down manner. Now the other side of the curve, if you imagine driving your car along that side, you're definitely going downhill, definitely. So that side of the curve, the right-hand side, is definitely decreasing. If you drive your car, you're decreasing, and it's decreasing in a concave down manner. So again, a lot of students think concave down means directionally down, and that's just not the case. Concave refers to the type of curvature in it. So like again, this one is increasing, but it's technically increasing concave down because of that curvature. Now, how are you gonna know numerically that it's concave down? Well, it has to do with the slopes again. So check it out. If I were to make up some numbers again, like right here, the slope right there is really positive. I'm gonna make up a number and say that the slope was 8. The slope right here is also positive, but not nearly as steep as it was earlier. So it's not quite as positive. Maybe I'm gonna make up a number and say that the slope is just 3. And then you notice the slope gets smaller and smaller and smaller and smaller until eventually you round the bend. Well, as soon as you round the bend, what's the slope right there? Well, it's definitely negative because I'm on that side of the curve now. So how negative is it? Well, it's not that steep. I'm gonna say that maybe the slope is -2. And then if you progress along, maybe right here. What's the slope right there? It's definitely negative, and it's pretty steep. So if I were to make up a number, I might say that the slope right there is -9. Okay, so check it out. What are these rates doing? How does 3 compare to 8? It's smaller. How does -2 compare to 3? It's smaller. How does -9 compare to -2? It's smaller. So again, kind of like on the previous one, if you imagine how these numbers would position themselves on a number line, 3 is to the left of 8. That confirms that it's a smaller number. -2 on a number line is to the left of 3. That confirms it's smaller. All of these numbers, if you track them on a number line, are getting progressively smaller as you go. So you'll know something is concave down if the rate of change is decreasing. Decreasing. When your rates of changes are decreasing, that's when you're on a concave down situation. If the rates of change are increasing, that's how you know you're in a concave up situation. My student in the past had a hilarious way of recognizing these in graphs. You'll see as we progress through this chapter, it can start to play tricks on your eyes with regards to when something is concave up or concave down. And so he used to say, and it's worked, my students laugh, but they love it. He used to say, if the curve has any chance of catching some cereal, then it's concave up. But if the curve is such that the cereal is just gonna roll right off the edge and not be caught at all by the bowl, then you know you're concave down. If it'll hold cereal, concave up. If it won't hold cereal, concave down. That's what he used to say. And I thought he was crazy when he said it, but my students ended up loving it. So I now use it from this point on. Okay, so there's our conversation about concavity. And as we progress through this chapter, we will definitely continue to talk about concavity. So come back to these notes and this kind of image when you need to. All right, so this portion is done. I'm going to stop this